Okay, in this video, I'm going to do the second part of the review packet for Chapter 3. So I believe it's problems 11 to 18. So this first problem says, find the exact values of the zeros of f of x. And then it gives you this hint. Okay, don't ignore this hint. This hint should tell you to use synthetic division. All right, so here's my polynomial. I look 4, 3, 2, 1, blast off. I have everything I need. If these are my roots, I'm going to do synthetic division twice, and that's how I'm going to get close to having all my zeros. So first I need to find the exact roots, and then I need to write it in factored form. Okay, so I've got two jobs here. So recognize that this is a two-part question. So I'm going to use the root of -3, and then I'm going to take a 1, a -3, a +3, a 37, and a -78. Remember, take the signs as well. Draw this big arrow, bring this guy all the way down. Don't bring it down as -3, bring it down as a 1. So -3 times 1 gives me -3. That's going to give me -6. That's going to give me +18. That's going to give me 21. And then -3 times that is going to give me -62. Excuse me, 63. Let me go back here, right? -63. And what is that going to give me? So let's figure out that math. Okay, so that's going to give me a negative, what, 26? Yes. And then -26 times a -3 is going to give me a +78, which is good news because I needed to have a 0 here because I knew that it had to be a root. Okay, so next thing. What does this give me for the quotient? That's going to give me a cubic, right? Because one step down. Do I have all the terms? So 3, 2, 1, blast off. I do. So look, don't even write it again. Instead, go ahead. I'm going to change color just to give you a little contrast. Use your next root. The next root is 2. What numbers do I take? Well, take the ones that you just got as an answer. So this is 1. This is -6. This is 21. This is -26. Okay? Now let's divide by that root. Bring down the 2. 2 times 1 is 2. That's going to give me a -4. 2 times -4 is going to give me a -8. And 21 and a -8 should give me a +13. And 2 times 13, oops, sorry. 2 times 13 gives me a 26. That's going to be a 0. Okay, so far, let's have a roots column. I have -3 and +2. Okay, this is a quadratic. Write that one out. This is y equals x squared, because the 1 is the coefficient, minus 4x plus 13. Now, nothing multiplies to 13 and adds to a -4. So that means that you have to use quadratic function at this point. So that means that for this test, you have to memorize quadratic function, which is x equals -b plus and minus the square root of b squared minus 4ac over 2a. Okay, you've got to commit that to memory, because if you memorize it incorrectly, you are going to be in a pickle because you're not going to get the answer that you need. Okay, so my a is 1, my b is -4, and my c is 13. So I'm getting x equals -b, so -4 is a +4, plus and minus. Okay, tell yourself, what is -4 times -4? That's b squared. That's a 16. It is not, and never will be, a -16. Okay, minus 4ac. Now, right away, I see I have an issue, right? It's going to be an interesting issue because I'm going to get a negative number here that's going to be greater than 6, but that's okay. So what's 4ac? Well, a is 1, c is 13. So what's negative 4 times 13? So that's a 12, carry the 1, 4 ones is 4. So that's a negative 52, all over 2a, which is just 2. Okay, so I have to figure out 16 minus 52. I know that's going to be a negative, but it's going to be a nice negative. So this is going to be x equals 4 plus and minus radical negative, don't lose the negative, 36 over 2. Now remember, what I said in the past is you have to be careful about those negatives under the radicals. They should not be there. So what should you do? Well, you should be pulling out the I, because that is radical negative 1. And now you have times radical 36, and what is that? That's a perfect square. So that's 6, all over 2. Okay, so can I clean this up? Now I'm going to reverse the I and the 6 because it's more properly written as 6i. So I'm just going to fix that right here because I don't have room for another step, but I would have just done another step. Okay, now this 2 in the denominator can go into both parts of the numerator. So 2 goes into itself one time, 2 goes into 4 2 times, 2 goes into 6 3 times. So 2 plus and minus 3i is my answer. So in terms of my roots little counted thing up here I have, this is 2 plus 3i, and this is 2 minus 3i. All right, so list your zeros on this line. So we were given negative 3 and 2, definitely list those. And then I just obtained 2 plus 3i and 2 minus 3i. And I obtained those using quadratic formula after I did synthetic division twice. Now, if you had done synthetic division first using a root of 2 and then using a root of negative 3, you would have gotten down to the exact same quadratic. So don't worry that the order is important. It is not. What is important is that you know the formula for quadratic formula like the back of your hand. That's important. It's also important that you know how to factor, hard factoring, easy factoring, 4-2 combo, greatest common factor factoring. All those things are important. Okay, so now let's write this in linear factored form. Linear factored form means that each of the factors has to have a power of only 1. So let's get going with that. Now this was f of x. I'm going to write it as f of x equals, okay, x minus a minus 3 is x plus 3, factor 1, x minus a 2. Okay, so this is x minus a 2 plus 3i, and then this is going to be x minus a 2 minus 3i. And you can leave it like that. That's totally fine. You don't need to clean up the last two factors. It's perfect the way it is. A lot of work here for this problem. Lots of things for you to know and go back over if you are shaky on them. Okay, so this says, draw an accurate graph of the following polynomial. Show all x-intercepts with their appropriate multiplicity shapes as well as the y-intercept. Okay, so let's do that. So things I take note of. Before I start drawing, I'm looking at this. I'm going to find the degree. So 1 and 3 is 4, 5, 6, 7. So the degree is 7. Now, why do I need that? I need it because I want to know what the end behavior is. The other thing that you don't want to miss sight of is that this is a negative. So negative means that my arms are going to look up, down. Again, you want to memorize those combinations. Okay, up, down is how that's going to look. So that's good to keep in mind. Now let's do the x-intercepts. So the first x-intercept, or root, or 0, be familiar with all three names, is going to be x plus 2 equals 0. So I have a negative 2, and it has a multiplicity of 1. Then I have x plus 1 is 0, so I have a negative 1, but that has a multiplicity of 3. Then I have a positive 1, and that has a multiplicity of 2, and then I have a 3 with a multiplicity of 1. So if I add multiplicities together, 3, 4, 5, 6, 7, I know that I've done everything correctly. Okay, now how do you get your y-intercept? This is sometimes a dilemma, so let me go over it. So this, I'm going to figure out how to get my y-intercept. So I'm going to look at this function. I have a negative. Write that negative down. Put a 0 in for every single x. If I put a 0 in for x plus 2, I get a 2. If I put a 0 in for x plus 1, I get a 1, but I get 3 of them. So I'm going to go like this. If I put a 0 in for x minus 1, I get a minus 1, and I get 2 of them. If I put a 0 in for x minus 3, I get a minus 3. So now let's figure out what we have. So I have, right here, I have a 3. Now, that's a negative 1. And this will give me a negative 2. Okay, so I have a negative 2 times a negative 1, which is a positive 2, times a 3. That's going to equal 6. Make sure you know how to do that. So my y-intercept is the point 0, 6, or you can just say it's 6. Okay, so now let's start putting in the important landmarks for my graph. So my x-intercept is negative 2. I'm going to put a little dot here. I'm going to count by ones. Negative 1. I have another little dot here. I have a positive 1, and I have a positive 3. And then I have a y-intercept, 1, 2, 3, 4, 5, 6 of 6. So I know I have to go up, down. Okay, so if I start up, and I know that my negative 2 has a multiplicity of 1, so I can start up and come right through it. Okay, I'm going to go down. I'm going to come up to my negative 1, and I'm going to kind of hang for a little bit. Hold on, I'm going to have to do this quicker, otherwise it gets crazy. So I'm going to hang a little bit here. So I'm just going to put a little line like that for myself. And then I'm going to come down to 1, and I'm going to boomerang off of it, and then come back down through 2. Okay, so let me see if I can do this quickly. So I'm going to go through here. So I have a negative 2. I'm going to come all the way down. I'm going to kind of hang a little bit, but go through, come up here. I'm going to go down to the 1. Oop, I'm going to boomerang, and then I'm going to come back down here. Boom, boom. Okay, so let me make sure I've done this correctly. At my root of negative 2, multiplicity is 1. That's good. At my root of negative 1, multiplicity is 3. I got that. I have my y-intercept. I have a multiplicity of 2 at my root of 1. I have that. And then a single multiplicity at 3. And my arms are going up, down. Done. Okay, that's how I want you to think this through. Okay? So that's the whole approach. Things that I know people have problems with: finding the y-intercept, applying the multiplicities, okay, knowing your directions. You've got to know all of that in order to do this problem correctly. Okay, so let's go on. Oh, and behavior. So let's talk about the end behavior. So I can see it right here and here. So I can say, as x approaches, it's always going to approach negative infinity on the left. Y is approaching positive infinity. On the right, as x is getting bigger and bigger, it's going to positive infinity. What's happening to y? It's going down, negative infinity. Okay? So why don't we do one little table here that's going to help. So, and that was a terrible looking table, so let me not do that. Okay, what about if I say the function and I say the leading coefficient? Okay, if my function is an even function and my leading coefficient is positive, what happens is my graph goes up, up. If my function is even, we'll do even again, and my leading coefficient is negative, the graph's going to be down, down. If my function is odd and my leading coefficient is positive, my graph's going to be down, up. And if my function is odd and my leading coefficient is negative, my graph's going to be up, down. Okay, this is what you want to memorize. Okay, you've got to have this in your mind, because if you don't, you're going to have a really hard time doing a problem like this. Okay, so let's go on to 13. Given the polynomial function Sx equals x to the 4 minus 3x squared minus 4, write Sx in fully factored form after finding its zeros. Okay, so fully factored form is going to be in the linear factored form, and keying on, this is a famous 4, 2. Okay, so I'm going to factor that. I'm going to first tell myself that I'm going to make a z, variable substitution, and I'm going to say that every z is x squared. I'm going to rewrite this. I'm going to rewrite it as z squared minus 3 times z minus 4. And I'm going to say to myself, what multiplies to negative 4 and adds to negative 3. And the things that do the 4 is going to be 2 and 2 and 4 and 1. And the difference here is 3, so it has to be this. And to get a negative 3, I have to have a negative 4 and a positive 1. So because my leading coefficient right here is a 1, I can just go directly to the factors. So I'm going to have z minus 4, and I'm going to have z plus 1. Okay, so I'm just going to check that mentally, make sure it works, and it does. Then I remember I don't really have z's, I really have x squares. So x squared minus 4 and x squared plus 1. Okay, so let's deal with these factors. I'm going to deal with them over here. So x squared minus 4 equals 0. X squared equals 4. X equals plus and minus radical 4. X equals plus and minus 2. Those are two roots. I'm happy with that. Then let's do x squared plus 1. So here's one set of working with my factors. X squared plus 1 equals 0. X squared equals negative 1. X equals plus and minus radical negative 1. You have to recognize that as I. Those are your other roots. So I have 4 zeros. So they are negative 2, positive 2, negative I, positive I. So write that in linear factored form. X minus a minus 2 is x plus 2. X minus a 2. X minus a minus I is x plus I. And x minus an I completes our picture. Okay, that's your linear form. This is your S of x, so I write that in as well. I have 4 roots. I needed 4 roots. I have 4 factors. I needed 4 factors. They're all linear. I am set to go. Okay, so then I have list its properties and sketch the graph of what I just figured out. Okay, so what am I going to do? I am going to do the following. I'm going to figure out my X-intercepts, and they are going to be at 2 and negative 2 with a multiplicity of 1. So here's negative 2, here's 2. X-intercept, because I have this form, the X-intercept is the gift. It's at negative 4. So 1, 2, 3, 4, there it is. The end behavior, it's a positive function. So my end behavior, what I'm going to think about is up, up. That is just a reminder. That just tells me my function is going to look like this. So I'm going to say, as x approaches negative infinity, y is going to be approaching positive infinity. As x approaches positive infinity, y is still going up because it was up, up. Okay, so let's get a little picture here. So the key thing is you cannot plot I and negative I. Okay, so this function is going to look pretty much like this. I can't tell it has imaginary roots. I can't tell it's still a function of 4. All I can see is that it has two roots. It appears to be a quadratic graphically, but it is not. It's actually a quartic. Okay, what's the domain? Well, the domain for any polynomial x is going to be all real numbers, which also you can write this way. Now the range, we have an even function, the range is going to be highly impacted by the y-intercept, which was, let me just get back on here, which was a -4, right? So the range starts low, it starts at -4, and then it goes forever. So even functions are impacted by the y-intercept, and they're not all real numbers for your range. They are always all real numbers for your domain. Okay, next thing. 14. Write in standard form a 4th degree polynomial with roots at 0 and x is 2 minus radical 5. Okay, they only gave me 2 roots. It's a 4th degree. I must have a double root here, and I have another root because I always have a conjugate pair, right? So my goal is to write it in standard form, but I have to first write it in factored form. So this is my factored form. Y equals, when you have roots of 0, then they appear as a single x in front of other factors. Because it's a double root, I'm going to say squared. Then I have x minus this root and x minus its conjugate. Okay, so what I want to do now is I want to begin to recognize the factors as a difference of perfect square factors. So to do that, I'm going to distribute that negative and write it like this. Okay, and then I like to use my color. So here's my A. Here is my B. And now suddenly it jumps out at me as factors of the difference of perfect squares. So therefore, when I multiply those together, I will get x minus 2 squared minus radical 5 squared, which is just 5. Okay, you've got to FOIL the x minus 2 squared. Don't distribute the power, but actually FOIL it out. And you have to use notes to the side to do that, and to be accurate, that's okay. The most important thing is that you do that piece correctly. Okay, so I'm going to keep going. This I can clean up. And now plus 4 minus 5 is a minus 1. I have to get it in standard form. This is still considered factored form. It's not linear factored form, but it's still factored form. So now I'm going to distribute the x squared everywhere. I get x to the 4th minus 4x cubed minus x squared. And I am done. So that is my standard form that I built from my radical form. So, or from my factored form. So what I wanted to mention is you are not going to ever see radicals in your function, in your polynomial function, nor will you see i's. So if you do all your math and you still have a radical, you'll still have an I, something is wrong, go back and fix it. Okay, factor and find all the zeros here. So I have 4 terms. That's a gift. Accept the gift. Factor by grouping. So I'm going to look at this group and then look at this group. Okay, let me just slide this down a little bit. There we go. Okay, so looking at the first group, they have a 4x squared in common. To get this first two terms back, I need an x minus 3. Verify that for yourself. Bring down this operation. I make this happen. And what number can go here? The number is 12. That gets me this back. Okay, so what do I have now? My factored form is going to be 4x squared plus 12 times x minus 3. Now, let's make my life a little bit easier. Can't I factor out a 4 and make this x squared plus 3? Okay, that's going to help me do the zeros. So 4 is not a factor. Okay, I need 3 roots. Set your factor of x squared plus 3 equal to 0. That gives me x squared equals negative 3. You know what's coming. X equals plus and minus radical negative 3, but I'm going to now do that as that. And my other one is going to give me x equals 3. And I have all 3 zeros, and I'm done. Okay, draw an example of a 6th degree polynomial that has a positive leading coefficient. Okay, that means it's going to be up, up. And the maximum possible number of turning points. You've got to know what that answer is. It is 5. Okay, so if you have 5 turning points, then that means that you must have all roots apparent. There's no imaginary roots. And none of them have multiplicities greater than 1. Those are my 2 takeaways there. So think about if that makes sense to you. Okay, so here I know it has to be, let me not do that, that looks terrible. Okay, so I know it has to be up, up. Okay, so let me just get some roots. I need 6 of them. So why don't I do 1, 2, 3, 4, 5, 6. So it's going to be up, up. I start up. I come in and out and in and out and in. How many turning points do I have? So let's highlight the turning points. 1, 2, 3, 4, 5 turning points. Bingo, done. Let's go on to 17. Find the location of the y-intercept for the following polynomials. Okay, we know how to do this. So you're going to replace all x values with 0. Okay, and don't ignore the negatives. The negative comes down. This is 0 minus 2, which is a minus 2, but I have 2 of them. Be careful about that. Put a 0 in for x plus 1. That's a 1, and I have 3 of those. What's my y-intercept? A negative times a negative is a positive, but times another negative should be negative 4. So negative 4 is my y-intercept. Okay, so make sure that makes sense to you. Let's do the next one. So same idea. Replace every single one of your x's with 0. That gives me a negative 4 here. It gives me a negative 1 3 times. It gives me a positive 1 twice. So these are negative 1. This is negative 4. This is 1. That's going to give me a positive 4. Okay, be able to do this. These are easy points. It just involves noticing your signs. Biggest mistake I see is ignoring this negative. You've got to bring that down. Other mistake I see is not taking note of the multiplicities. Got to do that. Okay, so remember you're replacing all the x values with 0. You are not setting the factors to 0 and solving. That is how you get your x-intercept. Okay, last one. Given a cubic polynomial with roots x equals 2 minus 3i and x equals 4, write it in linear factored form. Okay, So they gave me two roots. It's a cubic. I recognize that I have a conjugate pair here that's not explicitly stated. Write it out for yourself. Okay, get this in factored form. Remember, you subtract to the roots. This is going to be x minus a 2 minus 3i for the given root, and then x minus a 2 plus 3i for its conjugate pair. So I'm going to distribute the negative so that I can start recognizing it as a difference of perfect squares, factors. Okay, and then don't forget this is coming along for the ride. Okay, so let me continue with my obsessive highlighting. Here is A. Here is B. Okay, so when you FOIL the last two factors, you should be getting x minus 2 squared and then minus 9i squared. Okay, so make sure that you're okay with that. I still have x minus 4 here. Okay, so what's going to happen now? I'm going to FOIL the x minus 2, and I'm going to get x squared minus 4x plus 4. Do not mess that up. This is a negative 1. That's going to flip that sign. Okay, so I'm going to go to the next page, it looks like. So continuing on, I have x minus 4 here, and then this is going to be x squared minus 4x plus 13. And what I'm going to do now is distribute the x minus 4 to each of the terms in the trinomial. So this is a binomial times a trinomial. So x times everything gets me x cubed minus 4x squared plus 13x. A negative 4 times everything, and I'm going to stagger this. That's going to give me negative 4x squared plus 16x minus 4 times 3 is 12, 4 times 1 is 4, plus 1 is 5. Okay, so now add them up vertically, adding your columns up vertically, and I'm getting this plus 29, right, x minus 52, and there you go. Okay, so that's the last problem. So I know this video was long, I apologize for that, but hopefully you viewed it as a good teaching lesson as well. So good luck studying.